Welcome to the Slop Farm. Enjoy the video.
You start by securing the foundation. Pick AES 256 or CHA-CHA20 for encryption and choose local, encrypted cloud or hardware storage. Next, select a language with vetted crypto libraries like Python, Rust, or Go. Once chosen, initialize a new repo, add a minimal dependency list, and create a secure random master key generator. You must test key derivation immediately. Make sure to use PBKDF2 script or Argon2 with high iterations and salt. This begins your working prototype. You implement the core. Wire up Argon2 with sensible memory and time parameters and a unique salt per user. Then design an encrypted vault format including versioning and an HMAC for integrity. Once done, build add, read, and update functions that use atomic writes or file system temp rename to avoid corruption. Make sure to separate encryption from I/O and include clear error paths. Test with fixed vectors and fuzz inputs to validate correctness and catch edge cases early. You finish by adding a minimal CLI or GUI that masks the master key and prevents keylogging exposure. Then integrate secure export/import and backup that preserves encryption and integrity. Once complete, implement auto lock and session timeout. If something goes wrong, first verify KDF parameters and salt consistency, then confirm HMAC and non-C usage. Make sure atomic writes succeeded and backups aren't stale. Finally, document recovery steps and test restores until you can reliably recover the vault under failure conditions.
Thanks for watching. Consider subscribing if we helped you today.